Hi everyone, it's good to have you here again. It's another episode of FECAMDS UNTH Histology slide series. I am Akela Busayo. Today we'll be going through the slides of blood vessels. This shows the slide of the elastic artery. There are two main types of arteries. We have the elastic artery and then the muscular artery. The elastic arteries are large arterial vessels. They are large in such a way that a slide showing this vessel only takes a portion of the wall of the vessel. You can see that if you want to represent an elastic artery on the slide, it's only a portion of the vessel of the wall of the vessel that can be represented on the slide, just as you can see here, just a little part of the lumen and then a portion of the wall of the vessel. Now the wall of a blood vessel on a normal has three basic layers, which for that of the elastic artery we have a narrow tunica intima, which is adjacent to the lumen, and then a broad tunica media, and then the tunica adventitia, which is adjacent to the connective tissue that is surrounding the vessel. Now, the tunica media differentiates the elastic artery from other vessels. This layer is particularly broad and then extremely elastic. Earlier, we explained that the elastin fibers, which are characterized by its wavy appearance, is what makes up the bulk of the media of the tunica media. So in this slide, we can identify these wavy structures moving side by side in this tunica media. Now, these wavy structures, when they are stained with the Van Giessen or the elastin stain, it takes up a black stain, just as we can see in this slide. You can see that this wavy appearance has this black stain moving when you move from side to side. However, it can also be stained pink, just as in this slide is stained with both the Van Giessen stain and then the H&E stain. So that's why you can see that the elastin fibers here, some stains pink and some stain black. However, the tunica media also contains collagenous tissue, which are placed between the elastin fibers, so that we can see that not only the elastin fibers here stains pink, also the collagen tissue that are placed between the elastin fibers are also stained pink in this slide. So we can go again, as this is the tunica intima, then the tunica media, and then the tunica adventitia. This particular slide is stained by the H&E stain, and then as we said earlier in the first episode, that the elastin fibers can also be stained with H&E, of which they will take up a pink stain. So we can identify the lumen here, and then you can see our tunica intima, then the tunica media, the broad tunica media. Now in this tunica media, we can see the wavy appearance of the elastin fibers moving from up downwards. You can see this wavy appearance, but this time it's stained pink because of the H&E. This slide was stained mainly with the Van Giessen or the elastin stain. So that's why in this slide we can just map out the lumen of the artery and then the tunical media. You can see the tunical media of this slide. You can note it by the wavy appearance of these black fibers going from up downwards. So this wavy appearance, which characterizes the elastin fibers that are stained with the Van Giessen stain. This is also a slide of the elastic artery. Here the slide was stained with H&E, and then these folds we are seeing are just due to process of tissue preparation, and that it has nothing to do with the main structure of the slide itself. Now we can identify the lumen of this elastic artery, and then we can map out the narrow tunical intima, and then the rest of what we are seeing here is the tunical media. Now we can see the wavy appearance of the fibers that makes up the tunical media, which even though they are stained pink, it still shows the presence of the elastin fibers in the tunica media. So the reason for identification for elastic artery, you can say that the main reason for identification of the elastic artery is the presence of elastin fibers in the tunica media. So what are the examples of the elastic arteries? Mainly these are the large vessels, which include the aorta, the brachiocephalic trunk, the common carotid artery, the subclavian artery, and then most of the large pulmonary arterial vessels. This slide shows the muscular artery. Just like the elastic artery, the wall of the vessel has three layers: the tunical intimal, the tunical media, and then the tunical adventitia. Here, however, the vessel is small in size, such a way that the entire lumen and then the wall of the vessel can be represented on the slide. So we can identify the lumen as this part containing some blood cells, and then the tunical intimal, which is narrow, and the tunical medial, which is made up of concentric layer of smooth muscle cells. And it can also contain little or no elastin fibers. So then we can also identify the tunical adventitia, which is just adjacent to the connective tissue surrounding the artery. So for the muscular artery, the muscular tunical medial is usually relatively wide in size compared to what is seen in its corresponding muscular vein. So we can also see in this slide the lumen of this particular muscular artery containing some blood cells, and then just close to that is the tunical intima. You can see here then the broad or wide tunical media, and then you can identify the adventitia just around it. This also shows a slide of the muscular artery. Here we can identify the lumen, and then the tunical intima, then the tunical media, and then the tunical adventitia. One thing that characterizes most of the elastic arteries is that the lumen is rarely collapsible because of the thick muscular tunical media. So in this slide, even though it seems compressed, it is still not collapsed, unlike what we can see in this particular one, which is actually representing the muscular vein, which looks collapsed. Here we have a slide showing both the muscular artery and then the muscular vein. We can identify the muscular artery by its round lumen, then the tunical intima, the tunical media, which is relatively thick, and then the tunical adventitia. Here we can also see there's another vessel here. This vessel represents the muscular vein, and then this vein also has the tunical intima, the tunical media, and then the tunical adventitia. But here the tunical media is relatively thin compared to what we see in the muscular artery. And due to this thin or narrow tunical media, which also contains concentric layer of smooth muscle cells as what we see in the muscular artery, so the lumen of the muscular vein usually appear collapsed, just as we can see here. You can see that compared to the artery here, the lumen appears collapsed. Also, the lumen tend to be larger than its corresponding artery. So if this, take for example, this slide was cut in the same plane, and we can see that this particular vessel has a lumen that is larger than its artery. You can see it in the slide. This also gives a slide of both the muscular artery and then the muscular vein. Here we can identify the muscular artery by its thick tunical media compared to that of its corresponding vein. Even though the lumen tend to appear compressed in the slide, it still does not appear collapsed as what we see in this particular muscular vein. So we can see how thin this tunical media is compared to this. So this is the muscular vein, and then this is the muscular artery. We can even see how large the lumen is compared to what we see in this muscular artery. We can identify this as a muscular vein. We can see the wide and collapsible lumen, and then we can see the intima, and then the tunical media, which is thin. You can see how thin it is, the tunical media. This slide shows a comparison between the muscular artery and its corresponding vein. As you can see in the slide, the artery being smaller rounded and then thick-walled compared to the corresponding vein, which has a much larger lumen, which is irregularly shaped because of its collapsibility, and then a thin wall. So what are the reasons for identification for the muscular artery and the muscular vein? The muscular artery, actually, main reason for identification is the presence of a thick muscular tunica media and then the presence of a non-collapsible lumen. Then for the muscular vein, with the presence of a thin tunica media, then the presence of a collapsible lumen, and also the presence of a lumen that is larger than its corresponding muscular artery. Here we have another slide showing both the muscular artery and then the muscular vein. And in this particular slide, the lumen of these vessels contain blood cells. Now, the artery, even though it appeared compressed because of the process of tissue preparation it went through, we can still identify it by the presence of its thick muscular wall and then the small lumen compared to the corresponding muscular vein, which has a large lumen and then a thin wall. Now, what are the examples of the muscular arteries and veins? Now, these vessels, they mainly form the distributary branches and the tributaries of the arterial and venous tree. So, the examples include the radial artery and radial vein, the femoral artery and femoral vein, the coronary artery and coronary vein, the cerebral artery and the cerebral vein, and all other peripheral arteries and veins we can find in the body. So this is where we are going to pull the plug for today's episode. For any contribution and question, kindly comment below. And then please don't forget to like and subscribe. Thanks for watching.